This video talks about two real-world relations and does some analysis. So the first one we're going to look at is the cost of a banquet at Juan's Banquet Hall. It costs $4.50 for the room rental, plus $15 for each person served. The first thing that we're asked is what is the independent variable and what is the dependent variable. In this case, my independent variable is the number of people that attend, which is n, and then our dependent variable is going to be our total cost, which we can use as C. The next thing we're going to do is create a table of values for 50 people. So let's use n and C, and then we'll write our point on the graph. So for 0 people, our total cost is going to be $450, just the room rental. So that means that our point on the grid is going to be 0, 450. For 10 people, now we've got $450 plus $15 times 10 people, which is going to equal 600. So then my point on the grid would be 10, 600. And I'm going to continue on in the same manner. So 450 plus 15 times 20 will give me 750. And then my point on the grid is 20, 750. Same thing for 30. Here I would get a total cost of 900. 40, I would have 450 plus 15 times 40 will give me 1,050. And so I'd have 40, 1,050, 50, 450 plus 15 times 50, which is going to give me 1,200 here as my final cost. So 50 and 1,200. So now we're going to go ahead and plot that on the graph. On my x-axis, I'm going to put the number of people. And let's say 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay. And then on my y-axis here, I'm just going to do graph break, and I'm going to start at 450. And then I'm going to go up by 50. So 550, 650, 750, 850, 950, 1,050, 1,150, 1,250, and 1,350. And I'll do one more for good measure, 1,450. So now I'm going to put those points on my graph. So I've got 0, 450, 10, 600, 20, 750, 30, 900, 40, 1,050, and my last one, 50 and 1,200. Then I'm going to use my ruler to connect those dots, and I'm going to use a dotted line because I'm dealing with people, which is a discrete variable. I can't have decimals, so I use a ruler or a dotted line to represent that. And then I'm going to answer some questions about the relation. So first of all, is the relation linear or nonlinear? This one is definitely linear because my graph is a line, and because my rate of change is constant, which is shown in the first difference. So if I go back to my table of values, use a different color here, and I'm going to calculate the difference here. it's 150. Between my next two is also 150. Same thing, 150, 150, 150. So my change in cost is constant, and my change in my X value here, because I went up by 10 each time, means that my change in N is constant. Those two things, both being constant, means that my rate of change is constant for my relation. The next thing I'm going to do is use the graph to figure out the cost for 25 people. So using my ruler again, I'm going to go to 25 people, and I'm going to draw a line that goes right up to my graph. Then I'm going to turn the ruler horizontally, and I'm going to go to right where it meets my line, and I'm going to go over to my x-axis. And so I would probably estimate this is about 825. Okay. And then I can actually check and see if I can calculate it. So using the same approach I did in the table of values, my total cost is going to be $450 plus $15 times 25 people. Working that out gives me an actual cost of $825, which was the same as what I estimated on my graph. Okay, I estimated a little bit lower than my line on the graph because I can see that drawing with my ruler, my line is really actually probably a little bit lower here, just from where I place my ruler on the iPad. Okay. So then we can also make a prediction the other way, starting from the total cost. So let's use the graph. Use red to do that one. And so we're going to start at 1350 on my y-axis. And I'm going to go right over and through my line. Now I'm looking for the number of people that corresponds to that point. So I'm going to go right to where my red horizontal line meets my graph. I'm going to go all the way down, and I would estimate about 60 people. Using my approach here, I can still calculate it. I know that my total cost is $1350. I know that my base fee is $450. And I know that I paid $15 times N. I'm trying to figure out what value of N would go in there. So just like when we solved those one-step equations, I am going to move the 450 over and take it away from 1350. So that means that $900 of the cost comes from the people that attended. And to find the number of people, I'm going to divide both sides by 15. So that gives me 60 people. So my graph was actually pretty accurate. The second example that we're going to look at is the stopping distance of a car. And so here we have a table below that gives the minimum stopping distance. And what we want to figure out is the relationship linear or non-linear. In order to do that, I'm going to check my differences. So I'm going to check my speed first, which is my independent variable. And what it looks like is I've got a difference of 20 between each measure. So that's good. So that's constant. So my delta S for speed is 20. Now I'm going to check my stopping distance. So this is my dependent variable. So between my first two, I've got a difference of 8. Between my second two, I've got a difference of 10. Between these two, I've got a difference of 14. Between these two, I've got a difference of 23. And finally, I've got a difference of 30 between the last two. So my first difference is not constant. So the relationship is non-linear because it is not constant. So let's graph this and see what it looks like. Okay. So I'm going to put my speed on the x-axis and my stopping distance on the y-axis. This is in meters. This is in kilometers per hour. Okay. And let's go up here. We'll just go up by 10. So 20, 40, 60, 80, 100, 120, 140, 160, 180, all the way over there. And then on my x-axis, well, let's go up by 5s here. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, and we'll stop there. Okay, my first point is 0, 0. My second point is 20 and 8, so about here. Then I've got 40 and 18, so about here. Then 60 and 32, so about here. 80 and 55, and 100 and 85 all the way up here. Now I can't use the ruler, so what I'm going to do is the best I can with the eye pencil here. Okay. And I can see that I have a curve here. It is not a line, which reinforces the idea that my relationship is nonlinear. The last thing that we're going to do is just analysis on the graph. If a car stops after 70 meters, how fast is it traveling? So using my ruler, I'll do blue. I'm going to go to 70, let's say. So the car stops after 70 meters. So I'm starting on my y-axis. I'm going to go right over and right through my line. I'm going to turn my ruler and then go down to my x-axis. And based on my graph, I would estimate that it was traveling about 90 kilometers per hour.